We are doing hydrocarbons chapter. In the last class, we are discussing about the reactions of alkanes. So first reaction we discussed is about the substitution reactions by chlorine for alkanes. So there are 3 steps we discussed. First step is initiation, second step is propagation, and the third step is termination. So overall, the reaction between alkanes and halogens, which involve all these three steps, initiation, propagation, and termination step, this reaction is called the free radical substitution, because in all these steps your radicals are forming, and in the last step 2 radicals are combining and forming a bond. So what is a free radical substitution reaction? Which involves the reaction between alkanes and halogens involving initiation, propagation, and termination step is called free radical substitution. So this reaction is your homework question for today. That is, bromine can react with ethane to form bromoethane. We have studied for chlorine. Now the homework is for bromine. What conditions are needed for the reaction between ethane and bromine to take place? What do we call this type of reaction? And write an equation to show the reaction of ethane and bromine to form bromoethane. And why is this reaction not a good way to prepare a pure sample of bromoethane? So all these questions we discussed in the notes for chlorine. So same happens for bromine. So write down all the questions for homework. So we have discussed in the last class the substitution reaction for chlorine, that there are 3 steps: initiation, propagation, and the termination. So the reaction between alkanes and halogens involving all these 3 steps is called the free radical substitution reaction. Now this is your homework question, copy it. So this step you have to solve it now in the class, this question. Name the 3 steps in the mechanism of the reaction. Write an equation to show the first step in the mechanism, and what type of bond breaking does this first step involve? So name the 3 steps in the mechanism. Yes, Alicia, what are the 3 steps in the mechanism?
Initiation, propagation, and termination.
Yes, initiation, propagation, and termination. Now write an equation to show the first step in the mechanism, that is initiation step. So if you have to write down the equation for initiation step, your chlorine-chlorine bond will break. Cl2, it will break in the presence of UV light to form 2 Cl radicals. So equation should be Cl2 in the presence of UV light, it forms 2 chlorine radicals.
Cl or Br?
Sorry, yes?
Is it Cl or Br for this question?
Yes, it is Br, because in the previous question it is Br, right? Yes, it is Br. Okay, so bromine, Br, it is giving me 2 Br free radicals. What type of bond breaking does this first step involve?
Homolytic fission.
Yes, it is homolytic fission. Okay, bromine and bromine, since it is non-polar, so fish-headed curve arrows we can make, and we have bromine radical plus bromine radical, or we can say 2 bromine free radicals. Next, alkanes are completed. We have studied its combustion reaction also and its substitution reactions with halogens also. Next, we are moving further to the alkenes. So alkenes with one double bond per molecule, they have the general formula is CnH2n. For example, let us put n is equal to 2. So we get CnH2 into 2, that is C2H4 ethene. Similarly, for propene, we will put N is equal to 3. So C3 2 into 3 is equal to C3H6. It is your propene. Whereas alkanes, which contain only single bonds, are described as saturated hydrocarbons. Alkenes are unsaturated hydrocarbons. Okay, unsaturated hydrocarbons are compounds which have a double bond or a triple bond. So alkenes are unsaturated while alkanes are saturated. General formula is CnH2n. Okay. So after writing this slide, please tell me the formula for pentene. Tell me the formula for pentene.
C5H10.
Yes. Shaman, tell me the formula for heptene.
C7H14.
Yes. Okay, so this is about alkenes. Now, uses of alkenes are that oil refineries, they provide useful alkenes for the chemical industry. In the introduction of this chapter, we see how crude oil is separated into fractions at a refinery. That means how petroleum, it is separated into its different fractions: petrol, diesel, fuel, gasoline. Oil companies find that the demand for each fraction, it differs. So the lighter fractions, such as the gasoline fraction, they are in higher demand. Okay, gasoline is the lightest fraction. So chemical engineers convert some of the excess heavier fractions into lighter hydrocarbons for the use in industry. The large, less useful hydrocarbon molecules, they are broken down into smaller, more useful molecules, and the process is called cracking. So what is cracking? It is the process of breaking down of large molecules into smaller molecules, breaking down of alkenes into alkanes and hydrogen. Okay, why we are doing this? Why we are doing this cracking process? Because industries want lighter fractions. Okay, it is written that lighter fractions, they are in high demand for the industries. So we have to convert the heavier fractions into the lighter hydrocarbon. So this is the cracking process, that when large alkane molecules are cracked, they form smaller alkane molecules and alkene molecules. Example of a cracking reaction is given. This is what? This is alkane. Okay. So cracking is done in the presence of aluminium oxide, Al2O3 and heat. So we get CH3, CH2, 4CH3. That means smaller alkane and an alkene. Similarly, C10H22, we break it, we crack it, we get C6H14 plus what's left? After consuming 6 carbons, 4 carbons is left. After consuming 14 hydrogens, how many hydrogens are left? 8 hydrogens. Okay, so these are the examples of your cracking process. Write down. Okay, so you don't need to write this entire paragraph. You just need to write down the definition for alkene, that the process of converting the heavier alkenes into the lighter alkanes and alkenes, or the process in which your smaller alkenes are produced from larger alkanes is known as cracking. This is just for understanding. Done?
Yes.
Okay. So this is important. The reaction is important. Then write down the reaction. When large alkane molecules react, they form small alkane and alkenes, and also sometimes hydrogen.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
So as well as the cracking of alkenes can also be made by, so one process we have studied, preparation of alkenes, how alkenes are made by cracking of larger alkanes. Second is by elimination of a hydrogen halide from a halogen of alkane by heating with ethanolic sodium hydroxide. And the third is dehydration of an alcohol by using a heated catalyst, aluminum oxide, or a concentrated acid. Dehydration means, D means removal and hydration means water. So it means elimination of a water molecule from a reactant molecule. Okay, so write down this thing. I'll explain you by an example. Elimination of hydrogen halide from a halogen of alkane. Suppose we take CH3 CH2, Cl. This is what halogenoalkane, because Cl is halogen and it is alkane. So when you react it with ethanolic sodium hydroxide, okay, ethanolic means alcoholic. So I'm writing it's alcoholic sodium hydroxide. Then what happens? HCl is getting, HCl removes. Okay, Cl from here. Wait a minute. I'm writing it like this, representing all the bonds. It will be easier for you. What is the IUPAC name of this compound?
Chloropropane. Chloropropane.
Mono what?
Chloropropane.
Chloropropane, yes. You can call it chloropropane or 1-chloropropane, because at the counting will start from here. So it is chloropropane or 1-chloropropane. Okay. So when you react it with alcoholic KCN, ethanolic sodium hydroxide, then what happens? Dehydration will occur. Okay, so there is a formation of a double bond at this position where the chlorine is attached, where your halogen or functional group is attached. There is an elimination. So since chlorine is in the first position, so we get only one product here, but in other reactions we can get 2 or more products also. For example, if you remove this, then double bond will come here, so only there is one possibility. So you cannot determine the major products and minor products from here. But if I write it like this, CH3, CH, CH2, CH3. But if I write chlorine here at the second position, now 2 products can appear, 2 products we get. Okay, if I do the elimination reaction here, so you have to remove HCl, right? You have to remove what? HCl. So this carbon at which the chlorine is attached, it is called the alpha carbon. Okay, and the carbons which are adjacent to it are called the beta carbons. So this reaction is also known as beta elimination. That means what happens, at from alpha position remove the halogen, and from beta position remove the hydrogen. So suppose this is my first product and this is my second product. So what do we get? What do I get as the first product? You have to remove hydrogen from alpha, so it is CH2. Then you have to put a double bond and you have to remove what? Halogen from the alpha, CH2, CH3. Right? So this is my first product. And what is the second product? That you have to remove the hydrogen from the second beta position, from this position. So it is CH3, CH, double bond, CH, CH3. So these 2 products we get from this elimination reaction, because there are 2 beta carbons. If there is one beta carbon, you get only one product. Is it clear? What you have to do? Only 3 steps. First step is remove the halogen from the alpha carbon. Second step is remove the hydrogen from the beta carbon. And the third step is add a double bond between alpha and beta carbon. Okay. So this is first product and this is second product. Which is a major product? Major product is this second one, because it is the more substituted alkene, and more substituted alkene is the major product. So you can see here that this is my alkene. It is more substituted. Okay, so this is the major product as compared to this first one. Is it clear? Any doubt in this?
Yes.
So write it down. Okay, so the next reaction is dehydration of an alcohol by using a heated catalyst. So let us make an alcohol here, CH3, CH, OH, CH3. Suppose this is an alcohol. You are reacting it with the aluminum oxide or a concentrated acid. What happens at this carbon, which is attached to OH group, it is alpha carbon. So this is also the same as this. Okay, and these are my beta carbons. So removal of water will happen. So OH is removed from alpha carbon and hydrogen is removed from the beta carbon. So write down the product. Write down the product of this reaction. I am writing it as a skeletal formula now. This is the alcohol. Dehydration of alcohol you have to do. That means you have to remove water in the presence of H2SO4, which is a concentrated acid. So you know that at this position also hydrogen is present, and at this position, at first position also hydrogen is present, at second position also hydrogen is present. But which will give me a more substituted alkene, removing hydrogen from first position or removing hydrogen from second position? If I remove hydrogen from first position, I'll get this. But if I remove the hydrogen from the second position, I get this. So which is the major product? Okay. So this is a question that an alkene is known to be either but1-ene or but2-ene. You have to solve it now only in the class. That an alkene is known to be either it is but1-ene or but2. When heated with concentrated acidified potassium manganate solution KMnO4, bubbles of carbon dioxide gas were given off. You have to tell me which alkene is this, but1-ene or but2-ene. Okay. Pent2-ene is heated with concentrated. This is question number 1 and this is question number 2. It is heated with concentrated acidified potassium manganate solution. Draw the displayed formula of the products and name them. Write a balanced chemical equation for this reaction using O to show oxygen atoms involved. Please solve all these questions now. Name the first member of homologous series of alkenes. Give the molecular formula of alkene containing 18 carbon atoms and 1 CC bond. Look at the equation for cracking given in the text. Write a word equation for this reaction. Write a balanced equation to show cracking of nonane into heptane and ethene. Discuss and suggest why alkanes are more reactive than alkanes. This question you have to solve. So one by one give the answers. Name the first member of the homologous series of alkenes.
Ethane.
It is ethene. Give the molecular formula of the alkene containing 18 carbon atoms and 1 CC bond.
C18, C18 and then H36, I think.
Yes, C18 and H36, because the general formula for alkene is CnH2n, C18 and H2 into 18, that is 36. Tell me the word equation for cracking.
Like any word equation?
No, like any general word equation, like long chain alkane, it will give me shorter chain alkane plus alkene. So this is the word equation. Plus there are sometimes hydrogen also. Okay, so write a balanced equation to show the cracking of nonane into heptane and ethene.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
C9H20 gives like an arrow C7H16 plus C2H4.
Yes. C2 what?
H4.
Yes. Because we know the general formulas for alkane it is CnH2n plus 2 and for alkene it is CnH2n. For non that means 9 carbon atoms, hep means 7 carbon atoms, it means 2 carbon atoms. Next question. Discuss and suggest why alkenes are more reactive than alkanes. Alkenes are always more reactive than alkanes. So why alkenes are more reactive than alkanes? What do you think? Because of the presence of carbon-carbon double bond, right? Because of the presence of carbon-carbon double bond. And we know that this double bond consists of a sigma bond and a pi bond. Consists of one sigma and one pi bond. And if it is having a pi bond, so it is the pi bond is a region of high electron density. It is a region of high electron density. So it is more reactive. It is more exposed, so it is more reactive. Okay, and it is weaker than the sigma bond. So what do you think? The electrophiles will attack to the alkenes or nucleophiles will attack to the alkenes? They are having high electron density, double bonds, carbon-carbon double bonds are having high electron density. So electrophiles should attract or nucleophiles should attract?
Neutrophils?
First of all, tell me electrophiles are electron deficient or electron rich?
Ma'am, I didn't hear. What is electron deficient or electron rich?
I'm asking electrophiles are electron deficient or electron rich compounds?
They are electron deficient.
And what about nucleophiles?
Electron dense.
Yes. So what should be the answer? Alkenes are electron rich. So what should attack?
So
Electrophile or nucleophile?
Electrophilic addition?
Yes, electrophiles will attack because electron deficient electrophiles, it will attack to the electron rich alkenes. Okay, so electrophiles would attack alkenes. Electrophiles are electron deficient species which is always attracted to electron rich areas. And we know that the pi bond in alkenes, it provides the electron rich region and it is making a target for the electrophilic attack in reaction. If there's any doubt in any of the 5 questions, so please let me know. Or if it is clear, then please react with a thumbs up. I'll move forward.
Yes.
So now we learn about the addition reactions of the alkenes. Addition reaction of alkenes only. So most reactions of alkenes are example of addition reaction. In these reactions, one of the 2 bonds in carbon-carbon double bond, it is broken and a new single bond is formed from each of the 2 carbon atoms. That means from alkene to alkane. This is your addition reaction. Your one double carbon-carbon double bond is broken and a single bond is formed.
Yes.
So these are the examples. General equations for the addition reaction for the alkene. This is alkene with a hydrogen halide such as hydrogen bromide and with a halogen such as chlorine. So let us suppose it is hydrogen bromide and it is chlorine, Cl2. So hydrogen or X, it will attach to one carbon atom because it is symmetrical. Y will attach to one carbon atom. Here it is converted to single bond and Z and Z, that means chlorine and chlorine is attached. So this is the addition reaction of alkene.